is Algebra 3, Lesson 18, and it is Advanced Word Problems. So there are several different question types in here. Each of them is solved a little bit differently, but anytime this question type shows up, you'll solve it the same way. Does that make sense? Okay. So looking at this first question, okay, it says how many gallons of a 40% acid solution have to be mixed with 40 gallons of a 21% solution to obtain a solution that's 30% acid? Okay, so what we want to look at this is we want to look at this in terms of percent times amount. Okay, so the first part of the question tells me 40%. How many gallons of a 40% solution? So 40% is going to be written as 0.4, but I don't know how much, right? So I'm just going to put X there. All right, X is the amount of the 40% solution. Must be mixed with 40 gallons of a 21% solution. So I know the percent is 21, so it's going to be 0.21, and I know how many gallons it is, right? How many gallons is it? 40. All right. So it has to be mixed to get what is the percent of solution that I'm looking for? All right. So that's 0.3 times my amount. Do I know what my amount of the first one was? Do I know what my amount of the second one was? Really, in the end, those amounts have to be mixed together. So it's going to be X plus 40. If I can set this up, you guys should have no problem solving for X, right? Because we know right off the bat, we're going to go ahead and distribute the 0.21 or multiply the 0.21 into 40, right? 0.21 times 40 should be 8.4, right? Yes? Plus 8.4. Okay, then what do I do with the 0.3 on the right? Distribute it. Good. I got 0.3x plus, what is it, 1.2? Or is it 12? 12 plus 12, sorry. Okay, from here, right, we're simplifying. We're going to isolate x. So I'm going to subtract 0.3x minus 0.3x minus 8.4 over to the other side. Right, do all that kind of in the same line. That's going to give me 0.1x. And we're looking for 12 minus 8.4, which should give me what, 3.6? 3.6. What's my last step here? Divide by 0.1. Okay, x should equal what? 36, and I need a label on this because it's a real-world question. What is my label? What am I looking for? How many gallons? So it's going to take 36 gallons of a 40% solution. Okay, which this if you're asking where am I ever going to use this math, this is probably the easiest types of questions to answer that question for, because people use this stuff all the time. Okay, depending upon their field, depending upon what they're going into, but I would say especially farmers have to work with these types of equations. Okay, all right. Next one up on the list, all right, is a direct and inverse variation as it relates to a single equation. Okay, so these will always get solved the same way. They will give me all my information. I will have to solve for my constant. Once I have my constant, they'll give me new information. I'll plug my constant into the new equation and solve for the missing information. Okay, so they're going to start off with this and say oranges. Anytime O is a variable, I always put a line through it, because what could I confuse O with? 0. All right, so oranges varied directly. All right, just so you understand, if we have direct and inverse, direct always goes on top. Okay, direct will always go on top of the division bar, always vary directly as yellows, and inversely as blues squared. Okay, so does this make sense so far? All right, I have one thing that's missing. Can anybody tell me what's missing from my equation? If I deal with direct or inverse variation, I will always have a constant. And that constant will always be in the numerator. Okay? All right, so they tell me the first bit of information just tells me how to set up the equation, right? So that's the first thing I have to do. The second step is going to be taking the information. It says there are 18 oranges, and so the second step is just substitution. 18, let's see, 20 yellows, so I got 20K, and 5 blues. Okay, so I plug it in like that. Now we're going to solve for K. Okay, so step number 2 is substitute and solve for K. All right, so we have 18 equals 20K over 25. Okay, we can either simplify 20 over 25 or we can multiply by 25 and then divide by 20. Okay, all right, since nobody's talking. All right, that'll cancel that out. What's 18 times 25? 450. So 450 equals 20K. All right, we're going to divide by 20. Divide by 20. All right, so what is K? K equals, I think I heard somebody say it, but 22.5. All right, so again, first step, set up your equation. Second step, input information, solve for K. Third step is take the new information with my constant and solve for the missing variable. All right. They tell me how many oranges, so we're going to solve for oranges, and nearly every time we're going to solve for this last. Okay, we're going to solve for the thing that's on the left-hand side of the equation. How many oranges are there? Well, we know K is 22.5. Okay, but we're looking for, did they change the number of yellows on us? 12 yellows. And how many blues? 3 blues. Okay, so all this is going to get solved on the same side of the equation. So 12 times 22.5 divided by 9. Should be what? 30. Okay, 30. So 30 oranges. Okay, is that doable? Okay, I'm not saying that, you know, your start off equation won't always be the same, but the steps that follow it, right, the process will always remain the same. Okay, let's move on to word problem number 3. It looks like question number 1, but it's a little bit different. It says a solution of 46% alcohol is to be mixed with a solution of 23% alcohol to form 138 liters of a 43% solution. Okay? It says how many liters of the 46% solution must there be? Notice, do they give me amounts for either of those percent solutions? Okay. So this is what we have, is that we have an X and a Y. Okay, because we have 2 different types of solutions, correct? Now, X and Y here represent amounts of those solutions, because I don't know what the amounts are, but I do know what they add up to be. Can anybody tell me what they add up to be? They add up to be 138. Okay, that's important, because as we move on, okay, that first equation, all right, let's see, we got a 46%, so 0.46x plus, let's see, 0.23y. Okay, try to put that out there. Equals, we want to form, let's see, we're adding these things together to form 138 liters of a 43% solution. So 0.43 times 138. Okay? Okay, so we've solved these types of equations before, but can anybody tell me what is a quicker way to solve this question? A matrix. The only thing that I have to do first is what? Is multiply the 0.43 times the 138, right? Which, for your information, is 59.34. Now, if I wasn't going to use a matrix, does anybody know what we would do? Take this first equation and solve for one of the variables. So for instance, x equals 138 minus y, right? So I could take 0.46 times 138 minus y plus 0.23y equals 59.34. That's going to solve for y. In the end, that's probably not the solution that you wanted to jump to. You probably would have wanted to solve for the other one. You wanted to solve for x. Why? Because they want to know how much of the 46% solution, but we'll still get there. What's 0.46 times 138? 59.3. It should be what, like 63.4. So we got 63.48 minus 0.46y plus 0.23y equals 59.34. Okay. Then combine like terms. I'd go ahead and subtract 63.48 from both sides. Did anybody solve this using a matrix yet? Yeah, already solved it. Let's see, we got negative 0.46 and positive 0.23. That's going to be negative 0.23y equals, in our case, it's negative 4.14. Let's see if we come to the same answers. Divide by negative 2.3, or negative 0.23. Okay, so for y, we should get 18, right? So all I have to do is take, what was it, 138 minus 18, and that's going to give me 120 liters of the 46% solution. Okay, but like I said, can we solve it using a matrix? Yes, we can. So when do I use this equation? Whenever they give me two solutions but no amounts for those solutions. All right, we set them up as separate variables. Okay, so they might be the same substance, but they're going to be a different variable. Marissa, could you do the lesson or the 5 box for me? All right, let's keep moving here. Number 4. All right, the sum of the digits of a 2-digit counting number is 11. Now, the book has a really complicated way of doing this. I'm going to keep this much more simple. The sum of the digits of a 2-digit counting number is 11. So think about this for a second. There's 2-digit numbers, right? So the closest thing that's going to be 2 digits that add up to 11 is what, 3 and 8, right? Or 8 and 3, right? I've got that option, right? It could be what, 4 and 7, 7 and 4. Believe it or not, this is faster than the book's way of solving this, right? We've got what, 5 and 6, 6 and 5. Correct? Do we understand what we've done so far? Okay. So it says when the digits are reversed, the number is 45 greater than the original number. Okay? So meaning that the difference between 38 and 83, right? They both add up to 11, but we want to see what we get when we reverse them. All right? Is 83 minus 38? What is 83 minus 38? So because 83 minus 38 is 45, okay, it says what was the original number? Well, the original number would have been 38 then. Do you see how we can really, instead of going through a long equation way of processing this, we can use... There's only 1, 2, 3, 4, 5, 6 possibilities, right? So basically, if I can narrow my options for the answer down to 6 and then test them, right, I shouldn't ever get a wrong answer. Okay? Is anybody confused about this one? We got it? Okay. All right. Let's see, number 5. Number 5. How much pure water must be mixed with 6 pints of 80% developer to produce a mixture that is 36% developer. Okay, these are all worded really confusingly, but let's look at it like this. We have a percent, right? It's 80%, and we have 6 pints of it, right? But pure water has nothing in it, correct? So it would be, but we don't know how much of it. So we know it's 0%, but we don't know how much of it we have, right? But we do know what we get as a result. We get something that's 36%, and we're going to add our amounts together. Okay, so this is still basically question number 1, except what you have to understand is that you'll still see this question type show up independently because they're talking about water. Pure water is given as a 0%. Okay, so 0.86 times 6 should be what? 4.8, okay, plus 0x, okay, 0.36 times 6, 2.16, okay, plus 0.36x, okay. Let's see. So we're going to subtract 0.36x from 0x. 0 minus 0.36 is negative 0.36, right? And really, maybe the easier thing to do here, let's actually kind of take this back. Where have you guys been? I thought you guys were done. Oh, he wasn't. Okay. So imagine for a second we're just subtracting 0x. Okay? That's not going to change. It's still going to be 0.36x, right? But let's subtract 2.16 minus 2.16. What's 4.8 minus 2.16? 2.64 equals 0.36x. Okay, divide by 0.36. Okay, you should get like 7.33 repeating, right? Which is representing 7 1/3 pints. Okay? Again, real world questions require labels. So label. All right, hopefully we're paying attention. We're getting as much as we can out of this. Right? Okay, 6. What time are we out of here? 51? Okay, I'm going to go as long as I have to get as many of these done as I can. 6, Ivan's piggy bank contains only pennies and nickels. We've seen questions like this already, right? So, pennies plus nickels, okay? So we've got pennies and nickels. All right. When he counted the money, there was $10.23. So a penny's worth 1. 1p plus 5n is going to equal 10.23. Okay, I take the decimals out so I don't have to mess with it. All right. Okay. Let's see. Let's see. When he counted the money, there was $10.23. If there were 27 more nickels than pennies, 27 more nickels. So that would be nickels minus 27 is going to equal pennies, right? Yes? So if I want to solve this using a matrix, what I can do is let's see, that would be negative p plus n equals 27, right? Could I solve that using a matrix? All I did was take this equation up here and get p on the left, n next, 27 on the right. Do we understand all of that? So if you want to solve it doing it that way, you can. Okay, let's see if we get the same answer. If I'm going to solve it, I'm going to say that 1p, which is what a penny is worth, that's just simply n minus 27 plus 5n equals 1023. Okay, so that's 6n minus 27 equals 1023. Can add 27 to that. I've done this right. Okay, divide by 6. What do you get for nickels? Should be 175. Did I get that wrong? No, 175. Right, and we come back up here. We're going to take 1,020, or sorry, hold on. We know that there are 175 nickels, right? So all I have to do to find out how many pennies there are is take 175 and subtract 27 from it. 175 minus 27. 8. 148. Okay, 148 pennies. Did you guys get that when you did your matrix? Did you get 175 and 148? Yep, okay, good. Okay, let's see what we're down to. 7. 7's, there's like 11 questions here. What's that? All right. 500 liters of a solution was available, but the solution was 80% alcohol. Barry needed a solution which was 75% alcohol. How many liters of alcohol had to be extracted so that the solution would be 75% alcohol? What you have here is subtraction, right? So, oh gosh. All right, so the solution is 80% alcohol, okay? And he's got 500 liters of it, correct? We got to subtract something. We have to extract a certain amount so that what we wind up with is something that is 75%. So it's going to be 500 minus x. So it's similar to question number 1, but still different just because here we're not adding 2 to get something, we're subtracting to get something. So 0.8 times 500, kind of fast forward through here, I should get 400 minus x equals 375 minus 0.75x. Okay, I can add 1x to this, okay, and I can subtract 375. And you should get x equals 100 liters. Yep.